Beneath the Geneva gloom, far below the world's surface, lies a stunning triumph of human ingenuity, and an unavoidable sign of destruction. The Large Hadron Collider, or LHC, is a marvel of intelligent analysis, allowing scientists to probe the subatomic realm and triggering the discovery of the elusive Higgs boson, often dubbed the God particle. This breakthrough has captivated the scientific world, yet, as renowned physicist Brian Cox once ominously declared, a hidden potential has been uncovered at CERN, sparking a wave of curiosity and concern. Could our quest for knowledge have taken us down a dangerous path? Have we set our course for an uncertain future, possibly one that is beyond our comprehension? Prior to delving deeper into this startling statement, it's essential to first take a look at the gigantic machine that is the Large Hadron Collider. Operated by CERN, the LHC is an imposing 17-mile ring of superconducting magnets and is, by far, the largest and most powerful particle accelerator ever built. It stands as the pinnacle of scientific accomplishment, capable of recreating conditions that rival the universe's creation itself. This incredible apparatus allows researchers to investigate the fundamental components of the cosmos. But with such immense power, could it lead us to unanticipated effects, possibly even into the realm of the unknown and terrifying? Founded in 1954, CERN has become one of the world's most important and prestigious research centers, boasting 23 member states and a vast network of experts. While the LHC is its most high-profile project, it is only one part of an expansive array of accelerators and detectors aimed at understanding the universe's smallest components. The LHC is a race to uncover the very building blocks of existence. It accelerates protons to nearly the speed of light, sending them on a collision course that simulates the energy and conditions of the universe at its inception. The temperatures produced are millions of times hotter than the sun's core, while an intricate web of magnets guides these particles along their journey. At the same time, highly sophisticated cooling systems maintain the system's supercold environment, far colder than even outer space. The LHC is equipped with 1,232 dipole magnets that steer the proton beams and 392 quadrupole magnets that focus the beam just before they collide. Another crucial type of magnet helps increase the probability of collisions by pushing particles together with incredible force. Essentially, CERN's mission is to collide particles with such precision that it is akin to hitting two needles placed 6 meters apart. The accuracy required for this operation is mind-boggling, and the technology involved is unparalleled. The collider's construction deep underground, in concentric rings, shields it from the harmful effects of radiation. To achieve optimal performance, the entire system is cooled to -456 degrees Fahrenheit, colder than the vacuum of space. The underground setup houses 4 distinct particle detectors, ATLAS, CMS, ALICE, and LHCb, each with a unique purpose in investigating various aspects of particle physics. These detectors are equipped with massive cameras that capture the particle impacts, with experts constantly analyzing the data in search of traces of the elusive Higgs boson. The Higgs boson is thought to be integral to understanding the very fabric of the universe, offering insights into its essential structure. In many ways, studying the microcosm helps us unravel the macrocosm of the universe, much like completing an enormous cryptic jigsaw puzzle. However, with each new component we add, new questions and mysteries emerge, reminding us that every discovery leads to another challenge. The LHC is not merely a scientific tool, it is an embodiment of human ambition, progress, and the unwavering determination to comprehend the fundamental forces that shape our universe. But as we venture into the unknown, we must also confront the moral and existential dilemmas that accompany such daring exploration. What are the potential risks of delving into the unseen? Could our quest for understanding unleash forces beyond our control? Recently, a disturbing revelation has sent shockwaves through the scientific community. Brian Cox, a former CERN researcher and prominent voice in the field of particle physics, made a statement that has both intrigued and alarmed his colleagues. According to Cox, the LHC's mission to recreate a miniature version of the Big Bang, reproducing the very event that gave birth to our universe, could lead to unanticipated effects. The collider's impressive ability to probe the Higgs boson and investigate the dark enigma, a substance that makes up a significant portion of the universe, could potentially unlock truths beyond our comprehension. While the idea of uncovering the universe's deepest mysteries is exhilarating, it is also fraught with risk. The LHC recreates the extreme conditions present at the universe's inception, simulating temperatures, pressures, and energies unlike anything we can observe in everyday life. It is as if we are peering right into the present moment the universe began. Yet such immense power brings with it a huge responsibility to consider. Take the incident involving Russian physicist Anatoly Bugorsky in 1978. Bugorsky was pursuing research at the U-70 synchrotron at the Institute for High Energy Physics when a tragic accident occurred. A proton beam accidentally penetrated his skull, causing significant tissue damage, but he miraculously remained conscious and walked to seek medical attention. His experience serves as a stark reminder of the potential dangers that come with particle accelerators. The power harnessed by these machines should never be underestimated. Concerns about the LHC's capacity to create black holes, albeit on a very small scale, have raised alarm among some in the academic community. Black holes are regions of space with such intense gravity that not even light can escape. Some scientists have expressed concern that the LHC might create a miniature black hole, one that could theoretically consume the Earth from the inside. While researchers at CERN have reassured the public that any black holes created would almost immediately disappear and pose no threat to the planet, this theoretical possibility has still sparked curiosity and fear. The concept of forming a black hole by high-energy particle collisions has been the subject of much debate and has contributed to increasing awareness of the dangers associated with such potent experiments. To learn about the mechanisms of the LHC is crucial for grasping its potential to create a black hole. When protons are accelerated to nearly the speed of light and collide, the energy produced is so vast that it distorts the fabric of space-time itself. This effect can be likened to jumping on a trampoline, causing the surface to bend and warp. These distortions in space-time raise the unsettling question: could such shifts lead to the formation of a black hole? In the strange and mind-bending world of quantum physics, where the universe's fundamental laws appear to defy logic, there exists a theory suggesting that unknown aspects of our reality may be hidden within the very fabric of space. If such elements exist, the LHC could potentially tap into them, sparking the creation of a gravitational anomaly capable of forming a black hole. This possibility has garnered attention from some of the most distinguished scientists in the world, including the late Stephen Hawking. In his writing, "In conclusion, the Large Hadron Collider at CERN stands as symbolic evidence of human ingenuity and scientific achievement. It provides a unique window into the earliest moments of our universe and allows us to explore the very foundations of reality. Yet, this pursuit is not without its shadows. As we push forward into realms never before touched by human hands, we must remain vigilant. The very same technologies that unlock the secrets of the cosmos also possess the power to unsettle the balance we take for granted. The excitement of discovery must be tempered with caution, ethics, and deep reflection. Public dialogue is essential. The future of such experiments should not rest solely in the hands of scientists or politicians. It is a matter of global consequence. The LHC has become a symbol, not only of progress but of the profound responsibility that comes with understanding the universe on such a deep level. Should we continue to probe these frontiers, or should we pause to reconsider the implications of tampering with forces we are only beginning to grasp? The answer lies not just in equations and data, but in our collective values as a civilization. In the end, the LHC tells a story not only of atoms and particles, but of human courage, ambition, and the eternal quest to understand who we are and what reality truly means. Invaluable insights into the fundamental nature of the universe, but with such immense power comes a significant moral responsibility. As we continue to uncover the secrets of the cosmos, we must ensure that our pursuit of knowledge does not come at the expense of our safety or well-being. The LHC is a powerful tool in our quest for understanding, but it also serves as a stark illustration of the profound ethical considerations that come with exploring the unknown. As humanity pushes the boundaries of scientific discovery, the LHC remains an extraordinary example of our desire to understand the universe. The sheer scale of the project speaks volumes about the ambition behind it. Over 10,000 technicians, engineers, and scientists from all over the world collaborate to ensure the machine's success. The scale of the data collected by the LHC is overwhelming, with experiments that produce petabytes of data every year. The storage and processing power required to handle this immense amount of information demand cutting-edge technology that has revolutionized fields like computer science and data science. The results from the experiments at the LHC go far beyond particle physics, extending into areas like material science, medicine, and environmental studies. The study of the Higgs boson, for instance, could have far-reaching implications beyond our comprehension of the universe. The particle, which is integral to the standard model of particle physics, plays a crucial role in giving other particles mass. Without the Higgs field, the universe would be vastly different, with scattered particles in a state devoid of cohesion. However, beyond the fundamental comprehension of the Higgs, scientists are also keen to understand how the particle behaves under extreme conditions. These studies could lead to insights that impact everything from the development of new materials to understanding the fundamental forces that govern the universe. One of the other critical features of the LHC is its investigation of dark matter. Dark matter is an invisible substance that makes up about 27% of the universe's mass-energy content. Despite its immense presence, scientists have not yet detected dark matter directly. The LHC's experiments aim to expose the conceivable particles that may make up dark matter by observing the behavior of particles created during high-energy collisions. If dark matter is finally identified, it could change how we see the universe, unfolding hidden dimensions of spacetime and altering the foundations of modern physics. In addition to dark matter, the LHC is looking into other exotic realms, such as supersymmetry and the potential existence of extra dimensions. Supersymmetry is a theory that proposes a relationship between two basic classes of particles, bosons and fermions. This theory anticipates the existence of superpartners, particles that have yet to be observed. Supersymmetry, if found, could open the door to a new understanding of the fundamental forces of nature, offering deeper insight into the interactions that govern our world. Additionally, the LHC is essential in moving quantum computing forward. By understanding the behavior of subatomic particles, researchers can gain valuable insights that could revolutionize the way we process information. Quantum computers, based on the principles of quantum mechanics, have the potential to deal with issues that are currently beyond the reach of classical computers. The technologies developed for the LHC's experiments, such as specialized detectors and advanced computing algorithms, have already influenced the field of quantum computing, paving the way for future breakthroughs. Despite its undeniable benefits, the LHC's work also raises fundamental questions about the future of humanity. The search for the unknown can be exhilarating, but it also comes with the obligation of considering the possible unintended effects. The technology that drives the LHC could be used for purposes that could harm humanity, such as the development of advanced weapons or creating scenarios that are beyond our control. Ethical debates surrounding the LHC are not limited only to the possibility of catastrophic events like vacuum decay or black holes, but also include the potential application of the research. How do we ensure that this knowledge is used responsibly, and that the search for truth does not inadvertently lead to harm? As we explore the significance of participating in the unknown, ongoing conversations about the balance between scientific progress and ethical responsibility become essential. The global nature of the LHC's work requires the cooperation of multiple nations, each with its own values, priorities, and concerns. Transparency in research, accountability, and international cooperation will be essential in ensuring that the knowledge gained through these experiments benefits humanity as a whole, rather than causing unforeseen damage. The work of CERN through the LHC serves as a reminder that achievement must always be tempered with careful consideration of its broader consequences. Another issue of concern is the potential for unforeseen ecological impacts of particle accelerators. While the LHC is a relatively contained environment with no immediate environmental consequences, the enormous energy requirements of such machines are worth noting. The impact on the environment, particularly from accelerators that consume enormous quantities of electricity and produce heat, could strain natural ecosystems and resources. The LHC has enormous energy requirements, and although efforts are being made to use renewable sources and enhance efficiency, the larger issue of sustainable research in science must be addressed. Ultimately, the path forward will require a delicate balance. The LHC represents the desire of humanity for exploration, knowledge, and discovery. However, as with all scientific breakthroughs, there comes the need for ethical reflection and responsibility. The risks involved in such experiments cannot be ignored, but the potential rewards could restructure our perception of the universe in ways we can't even begin to imagine. As we continue this journey into the unknown, the focus must be on ensuring that scientific research and progress are conducted in a way that is safe, responsible, and beneficial for future generations. The Large Hadron Collider is much more than just a tool for scientific discovery, it is a representation of humanity's search for knowledge and its boundless curiosity concerning the nature of existence. The LHC's work has raised profound concerns and carries significant existential and moral weight. However, the LHC likewise demonstrates that by working together and ensuring careful oversight, we can uncover secrets that have the potential to change the course of history. As we stand on the precipice of these brand new findings, we must remain constantly aware of the potential dangers and committed to using the knowledge we ultimately discover in an ethical manner. The search for knowledge must always be guided by the obligation to safeguard our future. As we press forward into the frontiers of scientific inquiry, the LHC serves as a symbol of humanity's boundless curiosity and determination. Yet, it also serves as a reminder that with great power comes immense responsibility. The profound revelations about the universe that we are uncovering hold the potential to reshape our understanding of reality, but they must be approached with caution, humility, and a deep sense of ethical stewardship. One of the most pressing challenges of our time is ensuring that the knowledge gained through the LHC, and other scientific endeavors, is applied in ways that enhance the well-being of all people, rather than fostering division or harm. The global collaboration that underpins the LHC is one of its greatest strengths, highlighting the ability of people from diverse backgrounds and cultures to come together in pursuit of common goals. However, this international cooperation must be matched by a shared commitment to ethical standards that transcend borders, politics, and ideologies. The possibilities unlocked by the LHC are vast, from the potential for new technologies to unraveling the mysteries of the universe. Yet, as we advance, we must remain vigilant in ensuring that our discoveries do not outpace our ethical and moral considerations. As new frontiers in particle physics open up, the LHC will undoubtedly continue to push the boundaries of human knowledge, but it must also foster a broader conversation about how we, as a species, handle the knowledge we acquire. Moreover, as we explore these fundamental questions of existence, we cannot ignore the role that public perception and trust play in the acceptance of new scientific advancements. The LHC, as a high-profile project, must be transparent in its research and open to scrutiny from the public. By fostering a culture of inclusivity and engagement, we can ensure that scientific advancements are understood and supported by society at large. This will be crucial not only in advancing the science itself but also in maintaining the legitimacy of the scientific community. In the coming years, as the LHC continues to evolve and expand its research capabilities, it is essential that we continue to balance the pursuit of knowledge with a deep sense of responsibility. The research conducted at CERN has already made extraordinary contributions to our understanding of the universe, but it is equally important to consider the long-term implications of these discoveries. What does it mean for humanity to grasp the underlying mechanisms of existence? How will this knowledge influence our future, our technology, and our society? Ultimately, the LHC is not merely a scientific instrument, it is a reflection of the human spirit, our relentless quest for answers, our drive to understand the world around us, and our ambition to explore the unknown. But with every discovery, we are reminded that the pursuit of knowledge is not without its costs. As we continue to venture into uncharted territories, we must do so with a collective awareness of our responsibilities, guided by the principles of ethics, respect for the environment, and the welfare of future generations. The journey ahead will undoubtedly be filled with challenges and discoveries that we cannot yet foresee. But the LHC, as a symbol of human ingenuity and curiosity, reminds us that the pursuit of knowledge is one of our most defining traits. And as we look to the future, let us ensure that this pursuit is always guided by the best interests of humanity and the planet, ensuring that our thirst for understanding never compromises the integrity of the world we seek to understand.